All right, today we're going to talk about density, a property, a physical property of matter. Okay, so you probably heard about the word density. Oh, this, this is dense. You eat, like maybe you eat like a really good piece of cheesecake. You have really light cheesecake, or like sometimes you say a really dense cheesecake. So what density is, it's the amount of matter in an object. And this is based on the amount of matter in a given volume. Okay, so the two units that density is based on, the equation is density equals mass divided by volume. So the mass per given volume of an object. Um, to help you with your algebra, there's something called the triangle that helps you figure out if you're solving for different units. So density equals mass divided by volume. So if you were solving for density, that's mass divided by volume. So you'd cover up density, so cover this up, and you see m over v. If the problem's having you solve for volume, so cover up the v, you see m over d, which means you're going to do the mass divided by density. If you're solving for mass, cover up mass, and you see the d is next to the v, that means you're going to multiply. D, density times volume, would equal your mass. Okay, so the units that you're going to typically see, mass you're going to be seeing as grams. So you need to make sure that you're in grams. If you're in kilograms, you need to change that to grams. But you want, so like grams per liter, or you're going to be like grams per milliliters, or if you're working with like a cube, like a length times width times height, you would be grams per centimeters cubed. So those are the three units that you'll typically see for density. Now just to kind of give a picture of density here, there's something you can do at home with some common items. Let me switch over. Here we go. Okay, so this is all based on density, why we have these different layers here. So the bolts and the honey are the most dense things because they're at the bottom. And as you move your way up, you get less and less dense. So we have the ping pong ball and the lamp oil. Those are the least dense items here. So you have this layering effect that happens. You see this a lot with water and oil, where the oil is less dense, so it floats on top of the water. That's why in like the winter, ice floats on top of water. Ice is less dense than water. But you can make this really cool thing here if you really wanted to. If you had all these things at home, you can try that out. All right. Okay, so in the lab, you're going to have to, at some point, figure out the density of an irregularly shaped object, meaning an object that's not a perfect cube, a length, a width times a height. Okay, so how would you find the volume? Really, what this whole thing is, how to find the volume of an irregularly shaped object so you can find its density. You're going to first fill a graduated cylinder. Oops, whoa. A graduated cylinder with any amount of water, but you need to make sure you record this. Okay, so for example, maybe I had a graduated cylinder and I filled it up at exactly at the 50 milliliter mark. So maybe that's where I filled up my water, at the 50 milliliter mark. The next thing you're going to do is you're going to drop the object of interest that you're trying to figure out the volume of, or the density, into the water. So you're going to put the object into the water. Boop. Object. Okay, so this is like step 1. This is step 2. So next, you're going to record the new volume. So anyone that was kind of a fun trickster sort of kid, if you've ever filled your bathtub all the way to the top, and when you were a kid you did this and you went into it, well, you probably really saw like, oh, a bunch of water spills out once you get in. That's because you just did volume displacement. So the volume of water that comes out is going to be equal to the volume of your body that's under the water. So when you drop this object into the graduated cylinder, the water is going to go up, and let's say now it's at 60 milliliters. Okay, so this is with object. Okay, so that's with the object. So it was at 50 with just the water, now with 60 milliliters with the water and object. So now what you have to do is subtract those two volumes. So you have the volume of water and object minus the volume of your water that you had originally. Okay, so that number now represents the volume of your object. So in our situation here, we would have 60 milliliters minus 50 milliliters. So the object has a volume of 10 milliliters. So then you'd be able to use this to calculate density. If they give, you'd be given the mass as well. All right, so you're going to be doing that in the lab. We're going to do that in one of these problems here. But to get some practice here with calculating density, we're going to try, you can use either the equation or the triangle. I'm going to use the triangle just to kind of get you guys started with solving these for your algebra here. So an object has a mass of 13.5 grams and a volume of 90 milliliters. What is the density? Okay. So in the triangle here, I'll rewrite it over here. Density equals mass over volume. So grams, or you can have your volume as milliliters, liters, or centimeters cubed. Okay. So mass. Okay, so we are given 13.5 grams, and we have 90.0 milliliters. So what is the density? All right, so they're on top of each other. So do we have to multiply or divide? We are going to divide. Okay, so 13.5 divided by 90, and you would get 0.15. 0.15, so we want to use the correct units here. So density is mass divided by volume, so the mass we used was grams, and the volume in this particular problem is milliliters, so we're going to plug in milliliters as the volume part of our derived unit. There's your density. All right, next one. An object has a density of 2.4 grams per milliliter and a volume of 26.4 milliliters. What is the mass? Okay, so we're going to use the triangle equation to plug in our numbers here. The density they gave us is 2.4 grams per milliliter. The volume is 26.4 milliliters. So what is the mass? Okay, so they're next to each other. So do we multiply or divide? We multiply. Okay, so 2.4 times 26.4, and we get 63. So mass equals 63.360.4. Mass is going to be grams. Oops, oh, there we go. All right, next one. An object has a density of 9.4 grams per centimeters cubed and a mass of 35 grams. What is the volume? Okay. Okay, mass 35 grams, volume, or sorry, density 9.45 grams per centimeters cubed. So what is the volume? Okay, so 35 is on top of 9.45, so we're going to multiply or divide. We are going to divide. So your volume is equal to 35 divided by 9.45, and you will get 3.70. Now, the question is, what's the volume unit? So we're going to look at our density, mass divided by volume. So the volume that we used here is centimeters cubed. So this means that this volume is centimeters cubed. All right, so now for a little maybe trickier problems here that involve a little more work. Okay, a box has the dimensions 3 centimeters by 7 centimeters by 2 centimeters. The mass is 78 grams. What is the density? Okay, so they didn't give you an explicit volume here, but we know if we're working with a box that we can get the volume by having the length and width and height. So length times width times height. So in this case, we have 3 times 7 times 2 centimeters. So that is 42 centimeters cubed. So these are all centimeters. Centimeter times centimeter times centimeter. Okay, so that's your volume. Okay, so now we can plug in our numbers into our density equation here. So we don't know the density. We know the mass is 78 grams. We know the volume is 42 centimeters cubed. They're on top, so 78 divided by 42. So we get a density of 1.86, and density is 2 units, mass, grams, divided by the volume, which our volume in this case was centimeters cubed. Okay, last one. A student measures out 45 milliliters of water, drops in 15 pennies into the water, and the water level increases to 47 milliliters. The mass of the pennies is 13.5 grams. What is the density of these 15 pennies? Now, they gave us 2 volumes here. We don't need to know really the 15 penny part. We're not going to be plugging that in. That's our object. So we have 2 volumes. Volume of with the water, volume of the water with the pennies. So this is a volume displacement example. Volume displacement. Okay, so the bigger volume, water with the pennies, 47 milliliters, minus the 45 milliliters. So that tells us that our pennies, the 15 pennies, have a volume of 2 milliliters. The mass is 13.5 grams, so we can start plugging in our numbers here. So 13.5 grams mass. Volume is 2 milliliters. Density, we're trying to figure that out. Okay, so they're on top of each other, 13.5 divided by 2. So we get 6.75. Last thing is, what's the units here? Density is based on 2 units, mass divided by volume. So the mass, grams, divided by or over the volume in this case was milliliters. Okay, there you go. That was density. So again, if you need to slow down or rewind anything, that's the beauty of the videos. You can rewatch things and kind of double check how things work here. Okay, thank you.